Hi,
Hi.
what's going on?
I almost just killed my egg.
Okay, well, why don't you find like a nice safe spot for him?
I don't know, because we don't have our containers yet. I found my sister.
Um, let's see. You can borrow this
Oh,
small Kleenex box.
thank you. I don't know why you picked it.
Well, because she didn't want it to roll off her desk.
Wait, what's the name again? Benedict Cumberbatch.
All right. So today is the posted review day, right? Do you want to talk a little bit about questions or test format or any of that jazz here?
Yes.
Okay, let's do the test format first, and then we'll circle back and grab the questions following that. Okay. So let's just test format, like I got 7 questions on here. Now they're all multi-parters. So like, what the heck does 7 questions mean? I would say that, like excellent review would be looking at making sure you've done the problem set and reviews, as there are some problems that are essentially recycled versions of things that of situations you've done. Reminder that the equations that are on the review are the same equation sheet you'll get on the test, so you don't have to like lose your mind trying to memorize these things. I think for the most part, short of like SOHCAHTOA, I think everything that you kind of need is on here. I would say that the last thing that I would say would be that there will be one question on there that's like mega parts, like there are at the end of the part of the problem set. I think you have those couple of 2 questions at the end that have like a little bit more parts to them than usual. Okay, it's more than 3 questions at the end. So you definitely would want to make sure that, like, just FYI, they're going to be something similar there. So again, you'll find, they'll have, what is 1, 2, 3, 3 questions that are all finding lengths or angles inside of figures. Like 3 area volume questions. And then like the one big dog, like lots of parter, is probably a reasonable description. Like it's basically, they're just like the things you see in the review or in the problem set. So like not too shocking there. Let's so what do we you guys got some questions too that you wanna hit at, John? 12, you say? Okay. Okay. So for 12, it says the diagram shows a cylinder with radius 20, height 60, and we're asked to find the values for angle X and the value for angle Y. Okay. So here's a situation where the order in which you find these doesn't really matter. You could find X first or you could find Y first. So the value of one doesn't necessarily impact your ability to find the other one. So what I would do here, John, is to find X, I'll do that one first just because it's in order. I'm going to take this right triangle and then this right triangle, because I noticed that X is going to be the difference in angle DAB and CAB. Do you kind of see that? Okay. So angle DAB is just going to be the tan inverse of 60 over 20. And since this is the midpoint, we're told C is the midpoint, that's going to be tan inverse then of 30. Oops, I don't mean 20, I meant 40 there, because that whole side is 40. Cool with that? Okay. So then to do Y is going to be 180 minus this angle ACB, since they're a linear pair. And again, I like that because ACB is an angle inside of a right triangle. So that's going to be tan inverse of opposite, which is 40, over adjacent, which is 30. And that ought to do it. You could also have done this using the law of sines or cosines, but I think that's kind of a hassle. I'd rather use the right triangle trig if I can, because I think it's just, calculation-wise, it's a little bit simpler, and I don't run into a possibility of like a weird ambiguous case thing or something, and like, you know, feels safer that way to me. But if you had tried to do this a different way and use law of sines or cosines, this problem could be done in that way also. You would have had to solve for side AD first, and side AC, but you could have done that. Those are relatively easy to get just with Pythagorean theorems. And then you'd be able to use law of sines and cosines to kind of knock the rest of that out. I think that's a little bit overkill, but certainly still doable. John, does that feel okay? So that's the trick. Usually X is the tricky one that students have trouble seeing, that, oh yeah, that's just the difference of those two angles. Y is usually doable since it's a linear pair situation. Other questions? Yeah, Nat.
Can you do number
14? Sure. It says we got a rectangular box here with 80, 50, and 60 length sides. We're told M is the midpoint, so like I know that right away. And we're asked to calculate the lengths of ME and MF, which we know are the same. Okay. And then calculate the value of EMF. All right. So what I'm going to do is I notice that this triangle EMF is not a right triangle, right? So what I'm going to do is I'm going to start by building a calculation triangle involving either EM or EM or MF. It doesn't really matter which one. So I think that maybe, let's see. I probably would do this. Seems like a good one. Is that okay? Okay. So that's MCF. This is 60. I know that this triangle is 40, 50, and then that's the square root. So real quick, 40 squared plus 50 squared is square root 4,100. Oops, spot. So FM then is going to be that. Oops, wrong one. So 8775-ish. Does that feel okay to you? Okay, I just want to go and double check my answer keys as I'm going so that if I fat fingered something or whatever, I don't get like halfway through the problem and realize that I buggered it. Okay. That looks okay. So then we have a couple of options from here. I think probably be the easiest. Oops. Is if I split this guy down the middle. I can then find oops. EF is 80, but I know that that's 40 and 40. And I can, why am I able to do that split down the middle there? That because it's an isosceles triangle. So EMF is isosceles, so I can split it into two equal triangles like that. Two equal right triangles. That's the only kind of triangle I can do this with, though. So I need the fact that those two are equivalent in order to do this trick that I'm doing. Is that okay? Okay. So I can then say angle EM, I guess I'll call that side X, is equal to the tan inverse, oops, not tan inverse, the sine inverse of 40 over 8775. And then angle EMF is 2 times this angle EMX. Ah, that boogered me. Confound it. And then times 2, I get 5424, which I think is the correct answer when I just looked a moment ago. Does that feel okay?
Yeah.
Sure. Who else? Anybody else? Alyssa?
You do 31.
Sure. It's the last. So second to last one. Oh, maybe not even. Okay. All right. So part A says show that y equals 3x or 12 minus 3x. Okay. So I know that the perimeter is 48, right? Or the total edge length, I guess, is, maybe we'll say total edge length is 48. So let's think about here. How many x's do I have? I have 1, 2, 3, 4 of those. And then how many 2x's do I have? 1, 2, 3, 4 of those. And then how many y's do I have? I have 1, 2, 3, 4 of those. That should equal the total edge length, right? So if I divide that all by 4, I get x plus 2x plus y equals 12. And then I just subtract 3x from both sides. So there's my show. Does that feel okay? So when it says show, I want, like, you need to have all the work there for it, right? The show means, like, give me the work as to how I get this. Next thing it says, show that the volume of the container is this. Well, I know the volume is length times width times height. So x times 2x times y. So far, so good. And I know y from the previous problem is the same thing as 12 minus 3x. And then if I just distribute everything through, I have 24x squared minus 6x cubed. Does that feel okay? All right. So find the volume for which, or find the value of x for which v is maximum. So I'm going to just use my calculator to do this. So I'm going to take my volume equation that I just had written. And even if I wasn't able to do parts A and B, I can still do part C here because I have the volume equation given to me in part B, right? Which is what I'm looking to find the maximum value for. So if I go and I look at my values for x, I can figure out a reasonable bound here. So obviously if x is a side length, it can't be 0, or it has to be bigger than 0, right? So that makes that a good minimum. And if x is bigger than 4, that makes the y side length negative, which I know is bonkers, right, from part A. So my x value should be somewhere between 0 and 4. And I don't know what this is going to be. I'm just going to make my y max maybe 100, and I can always go back and look for something bigger if I need to. And I just hit graph. Okay, so I'm looking for this point that's the maximum. So easiest way to do that is second trace. Pick the maximum command. So the calculator is going to ask me 3 questions, left bound, right bound, and guess. So I'm just going to move my cursor somewhere to the left of that maximum. That spot looks fine. Then right bound, I'm going to move it to somewhere to the right side of it. That looks good. And then a guess, doesn't matter where it is as long as it's in between the left and right bounds. Since there's only one maximum in there, I'm just going to press enter right where I'm at. So it looks like 2.67 ish should be about the right answer there. I think those were, oh, they're meters. Sorry, meters. And then to find the maximum volume for that container, well, I have that right here, 56.89. Remember, the y coordinate is going to be the volume here, right? So I can just write that down. So meters cubed. And find the length and the height of the container then. So the length is equal to 2x. So that's going to be 2 times 2.67. So 534. And the height is y. So that's going to be 12 minus 3x. So 12 minus 3 times 2.67. So 399. Does that feel okay so far? Okay. It says the shipping container is to be painted. 1 liter of paint covers an area of 15 square meters. Paint comes in 4-liter containers. Calculate the number of tins of paint required to paint the shipping container. So I'm going to need the surface area for this figure. So that is 2 times length width plus 2 times length times height plus 2 times width times height. So that's 2 times 5.34 times 2.67 plus 2 times 5.34 times 3.99 plus 2 times 2.67 times 3.99. Oops. So 92.44-ish. Okay. So I know that if I can cover 1 liter of paint covers 15 square meters. So if I take this and so my liters of paint needed is going to be the surface area then divided by 15. So that's 6.16. And I know there's 4 liters of paint in a can. So when I take this and I divide it by 4, I get 1.54 tins, which should be, I need 2 tins of paint because I can't buy a tin and a half. You know what I mean? that feel okay, Alyssa? Sure. Again, nothing was like crazy complicated in here, but like you just, yeah, if you got lost about kind of what was going on or got confused on one of these parts, it's really easy to kind of freak yourself out and be like, oh, I can't do the rest of it. And it's like, no, you can. You know, it's okay. We can do it. You can do it. Anyways. Others questions? Yeah, sure. Scroll back there. 27. Okay. So I got this hemisphere stacked on top of a cylinder. Kind of looks like a grain silo to those of us that are into the whole farming thing. We want to find the volume and surface area for this thing. So the volume is just going to be the volume of the hemisphere plus the volume of the cylinder, right? So the volume for a hemisphere is half the volume of a sphere. And my volume for the cylinder is just pi r squared times the height. Does that look good? And the surface area then is going to just be the surface area for the hemisphere plus the surface area for the cylinder. But we're going to be minus the area of one of those circular bases because this base on the cylinder is covered by the hemisphere, right? Do you kind of see that? And if this was actually sitting on the ground as a silo, we wouldn't have to worry about this surface either. It doesn't say it's sitting on the ground anywhere, so I'm going to count it. Cool? Okay. So 1/2 of the surface area for the sphere, I forget, is that 3 pi or 4 pi r squared? I forget which one it is. Go and double check here before I write down the wrong thing. Yeah, it was 4. Good thing I double checked. You were on 27, right? I apologize for everybody that was watching this video that's now motion sick after me scrolling up and down rapidly, because woof, I would be if I were you. I think that'll do it. Is that cool? Yeah, if it's covered, if like one of the surfaces is now like on the inside of the shape, it's no longer a surface. So we can't count it. So the easiest way to usually is just like take the composites and then subtract off the pieces that are covered. Yeah. Volume, it's still like, if I take these two pieces, they contain this volume and this volume. I stick them together, no volume is lost. By sticking them together, it's still like holding the same stuff. But if it's a surface area thing, if I slap them together, like these two surfaces that I stuck together now are covered. So they're no longer surfaces. So I'd have to subtract those off. Does that make sense? And these are great questions to be asking, right? We want to make sure we're really clear about this sort of thing because it's easy to kind of goof that stuff up if you're just not thinking about it in the right way, you know? So these are good ones, guys. Can you read my chicken scratches? Okay. Who's next? Right? 19? Sure thing. Okay. It says the following diagram shows a hemispherical bowl with radius of 15. Some of the liquid is poured to the bowl to a height of 8. The circular surface with a circular surface of radius, of radius BC. Okay. Find the volume and then the surface area. What are we even asking for here? The volume of the water? The volume of the bowl? I'm confused at the wording of my own question here. I guess for the bowl it says calculate the volume. Okay. I guess. All right. Well, the volume of a hemisphere is going to be 1/2 the volume of the sphere. So 1/2 4 pi r cubed. Let's see here. So 7,068 and change cubic centimeters. Does that feel okay, Ray? Okay. And then for the surface area, it says, note the solid is a bowl with an open top. So we're calculating the outside surface only. So like if you're going to paint the outside of your bowl, the point of that is that the surface area for the hemisphere is just going to be exactly half the surface area for the sphere. We're not like this is now not a new surface because it wasn't like a solid ball that you cut in half and now you have a new surface. It's saying we're just counting the outside part of the bowl anyway. So like it's just telling you that it's exactly this. Yes, sir. So that's that. I don't know why we gave you this convoluted other stuff here because you didn't need the volume or the water or the whatever's going on. It would be more interesting if we asked for like the volume of the water in the bowl. But, or even more interesting would be the volume of it. How much more water could you add to the bowl? Because there you'd have to like do the volume of the bowl and the volume of the water and subtract the difference. That's a more interesting question. Maybe we'll change it. I don't know, probably not. I'll forget by the time it comes time to edit anything. Is that cool though?
Yeah.
Yeah, no problem. Alyssa?
29.
29, part B, you say? Okay, let's check here. I might see if I need any answers from the previous part. Oh, I guess not. Yuckarooskies. All right. Oh, just the roof. Well, that's not so bad then. Okay, so the roof is going to be 2 times the area of a rectangle plus 2 times the area of the triangle, because we're talking about that rectangle there, and then that triangle there. I guess, is that the roof? I guess I don't even know what we're counting as a roof. Well, we'll figure it out in a second when I check the answer and see if it matches, right? Okay. So the area of my rectangle is easy. That's just going to be 1.6 times 5. And in fact, that's got to be just the roof, right? Looking at my answer. The roof is just the part you would shingle. We wouldn't shingle this part of a house, right? Yeah, so the roof is just that. So that's going to be 8 times 2 or 16. It's all that like looking at the picture and thinking about comments. If you want the triangle in there also, that's a horse of a different color. That makes it a little bit more challenging. If I was going to paint the whole thing, you know, like, anyways, does that feel okay? If I wanted that triangle, I would probably use Heron's formula if I wanted the area of that triangle, since I know the side lengths of it, because I know this, this, and this. So I'd use that.
Can you show me that?
Yeah, where S is the semi-perimeter. So that's probably the way I would do it, although it is an isosceles triangle, so you could just do like the split down the middle and do some Pythagorean theoreming to get the height for the triangle and use 1/2 base times height, which wouldn't be difficult to do either, since it's an isosceles triangle, but you know, that would be fine to do also, not too much more difficult. Nat, is this a follow-up to this one that we're talking on? Yeah, sure. Yeah, sure. Well, because it's asking for the area of the roof. The roof would be the part you'd like shingle. If you think about your house, you don't put shingles on the front of your house. Like the triangle part's the front. The roof is just like the 2 rectangles. You know what I mean? So it's just like one of those like, oh yeah, what am I really looking at here? If you think about it, it's like, what does my house look like? It's just like, you know, or like the simplest version of a house, which is like a box with a triangle put on top of it. You know what I mean? Okay. You feel good though?
Yeah, I do.
Okay. So Nat, our volume is going to be the volume of the rectangle there. So the volume of the rectangular prism. And then we have plus the volume of this triangular prism on top, right? Okay. The volume for the rectangular prism is easy because it's just length times width times height. And then the volume for the triangular prism is going to be the area of the base, which is the triangle here, times the height of the prism, which is 5. So here is where I would use Heron's formula. So there, the A, B, and C would be 1.6. And the C would be 2.3. Does that feel okay? That's good enough for this, like just setting it up there? Okay. Or you could have done what I described to Alyssa and like think about it as an isosceles triangle and like split it down the middle. So this would be like 1.65 and that's 1.65 and that's 1.6, and you can Pythagorean theorem to get the height, do 1/2 base times height. You do it that way too. It's just less neat for me to write it down as a formula to fill in the work if I'm doing it that way, but it's equally as effective. You're welcome. I figured that triangle was going to come into play somewhere. It was the volume question, not the surface area question. Mostly because the surface area question was like the easiest possible surface area. We just overthought it. Anybody else? Okay. If you change your mind, you can always come up and talk to me individually or whatever, but we'll take the rest of the time here in class. You guys can work on what you need to be working on. If you run into something you're not sure about, or you want to ask about, or you just want some clarification, or need some help, or ask if something's okay, or any of the all of the above, you can just come up and bother me. Sound good? Okie doke.